As folks are joining us a few minutes in, the chat is if you could have an expertise level of anything right away, and some fun answers. But yeah, welcome. Lucas, thanks for sharing your screen. This is a presentation brought to you by Phidgets and CSTA, carpentry. Oh, cool. And I'm really excited because I just learned about Phidgets this year, and we were able to partner with Phidgets to kind of bring an opportunity for an introductory kit as well as a sensor, which is cool. So if you could go ahead to the next slides about introductions, Lucas, that would be awesome. So I'm Kate. I'm here to kind of help facilitate, but I'm not the expert on Phidgets. We have a couple folks who are on the call, but you've probably got emails from me. I'm sure I helped make sure that your membership experience is really strong and great, and excited to kind of help bring this together today. But Lucas, would you like to introduce yourself?
Yes, so hello everybody, thank you so much for joining us. My name is Lucas Passantrilli. I am an engineer and the education director at Phidgets. I'm excited to be here today and to talk about Phidgets a little bit.
Awesome, yeah, and please excuse me if I say your last name incorrectly, but we have Dr. Peter
Holoka. Let me save you the effort.
Thank you. All right. Well, if you could introduce yourself, and that would be great.
So I'm the Director of Educational Technology at West Point Grey Academy. We're an independent preparatory school in Vancouver, British Columbia. And I've never met Lucas prior to last year. We met at a conference. He was doing one thing, I was doing another. And I got to know Phidgets, and it basically answers all the most of the frustrations, if not all the frustrations I've had with the traditional robotics kits. So I'm happy to share it with you. He asked me to be on the call as an educator, and I'm happy to do it. That's how happy I'm with the product.
Awesome. Thanks so much. Yeah, so we have a couple, I mean, the focus of today is to kind of go through and talk about Phidgets, do a demo, get your questions answered. But if you want to go to the next slide, Lucas,
Yes.
I'll just go over a few housekeeping things before we kind of roll right into it. This webinar will be recorded, and it will be recorded. No one will see your faces or anything. It's just the person that's speaking. And the slide deck will be shared out. So if you miss anything, you'll definitely be able to revisit the information later. I do have everyone muted, but you will have an opportunity to ask questions throughout the presentation. And when we have gaps for time, we will go ahead and get those questions answered or at the end. So don't worry, we'll definitely have time for that. And then Peter is here to kind of share his experience on using Phidgets because we want to hear from other educators. So I'm here to kind of help facilitate, but main folks we'll be talking about Phidgets is Lucas and Peter. So Lucas, do you want to go ahead and head us off?
Yeah, perfect. So thank you. Just to start off, we want to say thanks to Kate, and thank you so much to Dr. Peter Holoka for joining us and talking a little bit about his experience. We really appreciate that. So as I mentioned, my name is Lucas. I am an engineer and the education director at Phidgets. So today, we're going to keep it pretty simple. We're not going to go too in depth. I want to just start with a very brief overview of what Phidgets actually are. So I know a lot of you are, brand new to Phidgets. You may have never heard of it before. So I'm just going to start off with that, and then we'll talk about this kit here. So, as part of this session, all of you will have received the kit, or maybe it's in the mail right now. So we'll just make sure everyone's on the same page with how to get that and how to actually use it. And then we'll kind of go into some coding a little bit with the Sonar Phidget. So I'm just going to show you all how the code works, what it looks like, and just get not too technical, but just a little bit so you guys understand. And then we'll end it off with 5 or 10 minutes of Peter sharing his experience and anything that he thinks may be valuable to you guys. So what I'm going to do is I'm going to kind of try not to make it, a 40 or 50-minute lecture. I'm going to take a pause every slide, try to look at the comments, and Kate's going to work with me and try to pass some questions on to me. So every once in a while, I'll take a break, take a sip of coffee, and just try to answer some questions so that we keep it, pretty casual, and hopefully everyone can enjoy it. So what I'm going to do is I'm going to minimize this, not fully, but just a little bit, because I'm going to start showing some code and stuff. So hopefully everybody can still see this well enough. And I guess one thing to note is if you all want to follow, there's a bit.ly link here. So what I'm going to do is I'll just paste it in the chat if you guys are interested in following along. And then this presentation, we'll leave it up for about a week, so you guys can head back in and take a look at anything specifically that you want to. So it's bit.ly Phidgets_CSTA. Alrighty, so to start it off, the first thing we're all wondering is what Phidgets actually are. So, we can see at the top of the list here, we say they're programmable USB sensors. So what they look like is this. So they all kind of look like this. They are sensors that are in this black enclosure. They kind of fit in the palm of your hand, and most of them do one specific task. So I guess one thing I should note too is if you guys are having a hard time seeing me in Zoom, you may all know this by now. You're probably all Zoom experts, but you can click on the single image. There's kind of multiple buttons on the black screen. So you should be able to select me individually or what is it called? Pin my video. And then you can usually drag it to make it bigger or smaller so that you can see. Yeah. So that might be useful if you're interested in looking at this stuff. So this is the Sonar Phidget. Again, fits in the palm of your hand. And again, all Phidgets do usually a single task. So there's hundreds of different Phidgets. This one measures distance. So, if I want to know how far away my hand is, I can use this Phidget to tell me. Here I have a light Phidget. So this is another Phidget. Again, same type of format. But in this situation, this one will tell me how much light is in the room, how much light is hitting, if I'm doing plants and I want to see how much light they're getting, things like that. The one that you guys get in your kit. So again, everyone will be getting this kit. The one on the back of it is called the humidity Phidget. So that one looks like this. And this one actually measures temperature and humidity. So this one does two things. So some Phidgets will do two things, but most of the time it's a single device that measures a single quantity. There's also things like motor controllers, so DC motors, servo controllers, brushless motors, so a wide variety of products. So that's what a Phidget is. And then what you do with your Phidgets is you take them. So I take the Sonar Phidget. What I do is I then take a Phidget cable. So this is a Phidget cable. And what I do is I plug it into my sensor. So I just kind of plug it in. I'll try to make it on the white part of my screen. So I plug it in like that. It just plugs in. And then what I'm doing after that is I take something called a Vint hub, which looks like this. So this is a 6-port hub, and it allows you to connect up to 6 Phidgets. So I'm taking the Sonar sensor. I'm going to plug it into one of the ports on the Vint hub like this. So now I have my Sonar sensor. I have my Vint hub. And then all I'm doing from there is I'm taking a standard USB cable. This is just a mini USB cable, and I'm plugging it into my Vint hub like this. So I have Sonar sensor, Vint hub, USB cable, and then all I'm doing is plugging this into my computer via USB. And then from there, what I do is I write a few lines of code. So I write this code in Java, I write it in Python, I write it in C#, I write it in Swift, really anything that you want to write it in. And then from there, I have access, we'll show you guys that in a second, but from there, I have access to this physical data without having to do any soldering, any wiring, any kind of breadboarding. So it's really cool. So that's the basic overview of what a Phidget system is. And then again, because I have a bunch of ports here, if I wanted to measure distance and temperature, I could add a temperature sensor. If I wanted to control a motor, I can control a motor. So there's a lot of options there. And we'll talk about more of that in a bit. So another really cool thing about Phidgets is that they're used by professionals. So our company has been around for 20 years, since the early 2000s, and we sell these devices, these exact same devices that we're using for education, to professionals. Sorry, I'm just taking a look at the chat quickly to make sure that nothing is, everyone can hear me or there's nothing crazy going on. So yeah, these are the exact same devices that you're seeing here. We sell to professionals. So engineers, computer scientists, researchers, all over the world use Phidgets, and they've been using Phidgets for the last 20 years. So that's a really cool thing for your students. You can give them a tool that they can actually legitimately take with them, as they move on in their careers. So what we have here, I have it in this spreadsheet or these slides, sorry. So if you are following along, you're able to check these out later, but I have some professional examples, and we're adding to this list all the time for our education users. But as you guys can see here, big companies use Phidgets. So if you name a Fortune 500 company, they probably use Phidgets. But looking specifically at these smaller companies and these not necessarily smaller, but just companies you may not have heard of. So this is an example out of Western Canada. So Triumph is a particle accelerator out of Western Canada, a really premier facility. They work directly with scientists at CERN, and they have Phidgets all over their lab. So I was there last year. That's actually when I met Peter, I believe it was that year. And I have some pictures here. So you can see on their desk here, they have the VinTub. In this project, what they were doing was they were using an encoder to basically they're trying to make this thing perfectly cylindrical. So they had this laser that was going around and measuring the distance, to the surface, and they were using a Phidget to track that laser around this thing. So there's some information down here about the specific experiment. That's a really cool example, and they had a bunch of Phidgets scattered all over their labs, motor controllers, all these types of things. Further down here, we have an example of this museum in New York. So I haven't visited this museum, but Phidgets are very popular with interactive exhibits and galleries and things like that. So in this situation, they were using again actually an encoder to track basically what this thing was you would write a positive statement in, and then you would spin the wheel and it would send it off into a ceiling where there was like a big display. And they were using Phidgets to track that movement and see how fast you're moving it so they could spit out the image faster, and a few other examples. So again, this is up here for you guys to check out. And what we also have, I just put an example of our videos. So what we're trying to do, we have a newsletter going out every month, and we try to add a professional example every month. So this is an example of a professor from the University of Cambridge in the UK, and he uses Phidgets in his research to monitor, tall trees and how they move with the wind for weather related information. So here's load cells, and this is what he would connect to a Phidget, and it's monitoring and gathering data, which he uses in his research. So really cool stuff, and a valuable source for your students if they're like, hey, what am I actually going to use computer science for? There's a ton of different applications. So that is the basic intro. What I'm going to do is quickly show you guys a Python program. I'm going to talk about Java and Python more later, but just to show you what this would actually look like. So what I have again is I have that set up where I had the VinTub and the Sonar sensor, and now I'm plugging it into my computer with that USB cable. And then what I'm going to do, I'm just going to clear this. I'll make this bigger so everyone can see. So this is a really simple project, and we're going to go through the code more later on. But basically I have 1, 2, 3 lines of code here. And if I run this program, I'm going to get distance measurements from my sensor. So hopefully you guys are able to see this in my screen, but I have the sensor there. And if I hold my hand in front of it, we can see the distance values change. And right now it's measuring, the distance to the ceiling, which is about 2 meters. But again, I'm in a high level programming environment. I'm in a Python environment. I'm not writing firmware. I'm not writing code directly to a chip. I'm in a nice programming environment, and then I'm able to get that physical data. So that's kind of the cool part about Phidgets.
Hey, Lucas, question,
Yes.
or we have a couple questions. I don't know maybe
Okay.
if you're going to answer these later, but hot questions off the press.
Cool.
I think
Perfect.
you mentioned something about JavaScript. Does it support JavaScript Phidgets?
Yes, yeah,
Okay.
we do. We don't. I'll talk about what we support in our course. So I think there was also a question about like, is there a curriculum for this, or how do I get it set up? So we'll talk about that in a second. But yeah, JavaScript is a supported language.
Great. Yeah, I think there's a question about, is there a video, or will you go through how to assemble the Phidgets kit that was received? And then the other question was, what kind of cable connects the sensor to the hub?
Okay, so yeah, so we will talk about how to assemble this. There's actually a full online guide for how to do this, so you guys don't have to worry about trying to write down any notes or anything. It's all online and all documented. And then I forget the second question you asked me.
Yeah, no worries. And now I have more questions, but perhaps
Okay, cool. We'll save them for the next slide. I think I'm going to take a pause every slide so that we can just.
Okay, yeah. I guess just
break
last question for this slide is, what
Sure.
kind of cable connects the sensor
right.
to the hub?
Okay, so we call these Phidget cables, but they're actually just a standard, it's like a Molex connector cable. It's basically just a 3-wire cable. You may have seen this if you use like analog sensors and different things like that. So it's just a simple 3-wire cable that you connect with your Phidgets to. So hopefully that answers that question. I can actually, there is like a specific code for it if you want to buy it from a different third-party site, but it's just a simple cable. Alrighty, so, and yeah, all the cables and everything are included in the box. So everything you need should be there.
And when I started this, I was suspicious, like many of you, where it's like, is it really as good? And it arrives in a box, and you sort of go through the tutorials. And my background is in network architecture, website design. I'm not a coding guy. I've been a CIO for nearly 20 years in education, but this sort of micro coding stuff, not my wheelhouse at all. And so this was sort of my first experience with it. And I was learning along with the kids in a lot of ways. And so really the tutorials are actually quite good, and they open you up to the concepts that are foundational, and then you can start exploring the enrichment stuff on your own. But I got to give them credit. The education side is quite well done.
Awesome.
So
Thank you.
yeah, and it sounds like maybe we can jump into like training and stuff in that later. But yeah, thanks so much. And we'll get questions that are in the chat. Don't worry, we'll get to them. So go ahead, Lucas.
Okay, perfect. Okay, so we've talked a little bit about what Phidgets are, who uses them. So now what we're going to do is we're going to split from this Phidgets device thing to the education sector. So, we have two kind of things we're talking about, Phidgets, and then now we're going to talk about education specifically. So the first thing to talk about is just a little bit of like, just making sure everyone's on the same page. So if you join this webinar without signing up, make sure that you follow this link right here, this educate. I'm going to put it in the chat just to be sure that everyone has it. So everyone, there we go. So that will bring you to a form that you can fill in. And then I'm just going to actually go to that right here so that everyone can see. Make sure that on the bottom of the form, there's this promotional code. Just make sure that you're entering CSTA plus. And if you do that, you will get not only will you get the kit, but you'll also get this bonus sensor, which is the Sonar sensor that we just saw. So if you haven't done that yet, make sure that you have that filled in, and we will send you that for free. So I just wanted to do that quickly to make sure everyone knows how they can get their kit. I think most everybody has already filled it in. Okay, so now you have this kit. And again, now we're talking specifically about education. So I have this kit. I'm an educator. This kit's only available to educators. So how do I actually use it? So what you're going to want to do is go to this URL here, which is phidgets.com/start. If you look on the side of your box, you'll also see it there. I'm not sure if you guys can see it in my video, but it's right on the side of the box there, so that if you give this to a student, you can say, hey, just go to that link on the box, and that will get them to the right spot. So if I click on that, I'm just going to exit this. If I click on this link here, this is now going to bring us to the tutorial for this kit. So this is where all the information is that you guys need to get started. So just looking at the basic overview of it, here we have the introduction. So again, this is the best way to introduce this to a student, to introduce Phidgets to a student. So this will tell you everything you need to know about Phidgets, how to get started, everything like that. What we have here is we have a short video that I'd really recommend your students watching. It has some really good examples of people that use Phidgets, from Caltech, Carnegie Mellon, all these examples. We interviewed a local business who actually uses Phidgets, and the owner there talks a little bit about how he uses Phidgets. So just some really cool examples. And again, it just gets them in this mindset of like, okay, this is why I'm learning this thing. This is not like a toy that I'm learning. It's a real tool. So it's a really cool video. I'd recommend checking that out. And then from there, what you're going to want to do is you're going to want to start by setting your language and your environment. So as I mentioned before, you can code this in most mainstream programming languages. So for the education section specifically, right now we're offering it in these languages. I know there's been a decent amount of requests for JavaScript. So that's probably something we're going to see here as a listed language in the future. But right now we have Java and Python as the two kind of main languages that people are using. And we also have C# and Swift for some other schools who are using those. So what you're going to want to do is make sure that they have selected, if they're on Windows, and today I'm going to be using Python, for example. So I'm going to select Windows, Python, and Thonny. But again, you would make sure that your students are selecting whatever environment they're in. So then you press done, and then that configures the site to work with that language. if you want to change the language, if you scroll up, you'll see right up here, there's this little image of the Python logo. So you can always click on that. And then from there, you can always change that. So this is just to make sure that all the instructions on the site work for them. So we had a question about building the kit. So, step one of this course is building that kit. So if I jump into this, we're going to see the assembly. So on the left-hand side for the getting started kit, you're always going to see an overview of what there is to do in this section. And then here you'll have all the steps. So one thing to note is you can click on these images, it will expand them and just make sure that everyone can get a good idea of what they're supposed to be doing. So the first section is all of these buttons and LEDs, they come inside of the kit. So you're taking them out of the bags and you're just assembling it, and you actually use that shipping kit, the shipping box, as your little controller, which is nice. So then from there, you move on to assembling the LEDs. And again, there's really not much to assemble here. You're just you get the LEDs and you're just putting them in the box, and you're just making sure that in the next step that they're connecting to the correct port. So at this step, we're just saying, hey, here's how you wire this thing. And inside of this kit, you'll see that VIN tub that we mentioned earlier. So that's all that's in there. So in the kit, you get a VIN tub, you get the humidity sensor, you get buttons and LEDs, and you get a pretty good start for your Phidgets projects. Alrighty. So then after this, this step, you're adding the humidity sensor. We talked about this a little bit earlier. So this one measures temperature and humidity, and then you're moving on from there, and you're kind of done. So I'm going to jump up here to this breadcrumb here. So at this point, this is where you want to go to. If you haven't built your kit yet, that's where you want to be. The next step is the configure step, which is actually quite important. So this is one of the most important steps in this kit, because it shows your students how to actually set this up for their environment. So in this situation, because I've set Thonny, I'm getting Thonny instructions. So this is how I would, how a student would configure their environment for Thonny. We also have video instructions available if your students prefer that. So there's this thing here that you can click, and it will give you a video instruction where someone is dictating exactly what to do, and there's audio and stuff if the student learns better that way. So, and I'm just going to show you guys really quickly right here how I would configure Python. So it's really quite simple. On a Windows machine, all you would do is, if you had it just a totally blank, I'm not sure how many people are using Thonny, but if you're using a different Python environment, it's very similar. All you're doing is you're going to your package manager. So I'm going to my package manager here, and then all I'm doing is searching for Phidget 22 native, and then I'm just installing that package. So on a Windows machine, that's all you have to do, and from there you can start coding. So it's really simple. Right now on a Mac, it does require an install. For Windows, there is no install. For Mac, there is an install. So that is something to note if you are on a Mac machine. Awesome. So that is the configure step. So again, this is really important, and this is something that your students are going to probably go through a few times as they build different projects. So after you finish the building of your kit and configuring your environment, then you move on to the next step, which is actually using your kit. So if I click on this blink LED step, this is the first step. This is where we learn how to actually write code against this device. So again, we see a similar flow here. We have all of the steps of lesson 1. So overview, write code, practice, troubleshoot, and then we have an overview. So in this section, you'll be learning how to blink an LED. We scroll down, we see that we're in Python here. If I needed to change my language, I can set my preferences here, and I would be able to change that language to Java. But this is where we get the code that we want. So in this section, I can either copy the code with this button up here, or I can just highlight it. And then what I would do is I would copy this. I would open my Thonny project. I would create a new file, and then I would just paste this in. And then from there, I can run it. So they always get the base code to get them going. And then after they run this and they blink their LED, they're scrolling down and they're having their assessment. So this is practice, but it's also a way for educators to assess what their students are doing. So these are leveled questions. So step 1 is easy. It gets harder as you go along. And this is what's getting them to kind of go back into that code and make sure that they understand what's actually happening. So in this first question, it's asking them to modify the code so the LED stays on for 2 seconds. So they go back, they can use these hover over links here to get more information about a specific section. And then basically they're just trying to change this sleep statement in this step to 2 seconds. So that is step 1, is learning how to use a button. So this is the kind of simplest introduction. You're not doing anything with the Phidget yet. You're just doing the button. Lesson 2, you're going to go into reading, the LED was the first step. Lesson 2, you're going to go into reading the buttons. So, reading input from this button, you just output to an LED. And again, it's a very similar format where you have the lesson overview, write code, practice, troubleshoot. And everything is the same kind of way. So you would copy this into your code, you'd run it, and then you'd come back into this as a student, and you would modify your code. So what's happening right now, we have a lot of schools who are deploying this remotely. So what they'll do is they'll have, this kit, the student will pick it up at the beginning of the semester, or, whenever they're about to use it. And then what we've had teachers do is they say, okay, lesson 1 is due, say they're doing this project-based learning for a week. So lesson 1 is due on Monday, lesson 2 is due Tuesday, and they'll go through the code with the student and say, okay, like via video, which did you get number 1 done? Did you get number 2 done? Did you get number 3 done? And then they'll talk about how they got that done. And, it's a nice way to assess them. So after that, what you'll do is the students will learn how to use both the LEDs and the buttons. And then after this lesson, we have a project at the end. So we always have projects at the end of every section, so that again, it's a good way to assess and also for the student to investigate the code. So here, you're doing a project where you're counting the number of button presses, and it's like a tug of war. So whoever gets to 10 button presses first wins. And in this situation, you're using variables to store that count. You're using conditionals. You're using all the stuff that all these computer science skills that they need, all these coding skills that they need. So I'm going to use this breadcrumb link right here, and I'm going to jump back. So if we look at this now, we've completed the simple Phidget step. Again, that's just teaching us to use these. We call these simple Phidgets because they're not, these are kind of smart Phidgets, we say, and things like LEDs and buttons, analog sensors, those are all simple Phidgets. So after that, what the student will do is they'll jump into the smart Phidget section. So this is reading temperature, reading humidity. And again, there's a practice at the end where they're putting that all together. And then finally, there's a final challenge where they're putting everything together. So the temperature sensor, the humidity sensor, the buttons, the LEDs, and they're building like a smart thermostat. So again, another project that they can do. And that is the end of the basic getting started kit. And then what we have at the very bottom, you guys will see, is this advanced lesson section. So again, if you have a student who is looking for a challenge, who wants to kind of dive deeper, this is a great place to be. So they can learn about advanced methods. So this one, for example, is LED brightness. So they can learn about an advanced method to change the brightness of their LED. If you're using events in your class, so if you teach Java and you're learning about listeners, this would be a way to introduce that. So instead of polling the button, you're waiting for an event. This is a cool example. This is showing them how to use multiple Vint hubs. So this one actually has a picture at the bottom showing a professional installation of Phidgets. So, in this situation, we have multiple Vint hubs controlling multiple Phidgets. So this is some really awesome control panel these guys have made. So this is showing them how to use 2 Vint hubs instead of just 1. So kind of a cool little section there. And at the end, we just have we have things like APIs, which are actually new. They just were launched this month. So some really cool stuff if you have students who are really willing to peel back the layers on this professional tool. And before I end this section, one thing I want to mention is in the news tab up here, we have this news tab. If you click on that, we have usually our own internal webinars that we run almost weekly. But if you're looking for a more in-depth overview of the kit, of the Getting Started kit, you can always find the webinar that is in your specific language. And you can click on these links and they'll bring you to a video. So like this one, for example, is Python. So it's 43 minutes and it's specifically on Python. So you'll have all that information. Okay, so I'm going to go back here and pause for a bit and see if there's any questions. I think the chat was kind of going crazy, so hopefully I can answer some questions.
But in a good way, I think a lot of folks are curious how to use things. Some questions are on like where to ship things, but
Right.
compatibility questions. Now would be a good time to throw your question in the chat if it wasn't answered already.
Yeah, I'll take a look at and see if there's anything I can answer here. Oh, I see some, I got some private ones too.
I don't
Okay,
know
so
if Rosa's question was answered. It might have been, but how do you get the cable out of the VINT hub?
okay, that's a good question actually. So one thing to make sure is once you have the cable inside the hub, there's a little tab that a lot of students don't notice. I'll try to make it so it's on the white part. There's a little tab. So you really want to make sure that you're pushing the tab and kind of applying like a downward force, and it will come out. So that's the best way to do it. Hopefully that makes sense. There's a little tab and you just want to make sure you're kind of pulling down and pushing the tab. So one question too that I just saw here was about like online IDs. So right now, everything is on a, like basically the idea with Phidgets right now is that it's really good for students in grades 9 to 12. And what we've seen in most high schools is there's like a computer lab where they're writing their code, and that's the way like they kind of have their lab set up. But in the future, so in about by September 2021, we're going to have online support. So you can go to Scratch. We actually have a Scratch beta right now that you can sign up for. We're going to get Scratch support. We're getting like an online Python / JavaScript editor, things like that. So that will be available, but right now it is not. So that would be the Chromebook situation. So right now we do not support Chromebooks, but we will in the future. So hopefully that answers a few questions. Let's see. Visual Studio. Yeah, hopefully. I had a question privately about if you didn't get the Sonar sensor as part of your kit, just maybe email me at the end and I'll make sure that you get a sensor sent to you, because sometimes if the promotional code wasn't there, it may not have kind of got through to you. But I have my email linked at the bottom of these slides, or I think it's just the education email, but just send an email out and we'll get that sorted out for you. Alrighty, so I think I'm going to move on to the next step, which is diving a little bit into the code. Not too much, but just taking a sensor, kind of moving away from the getting started kit. So hopefully that was a good introduction and everyone knows how to use this kit. This is basically the main way we would recommend introducing students to Phidgets, just because the course is so well thought out and built out. It's really made for people who have never experienced Phidgets before and they're just getting started. So after you've kind of completed the kit, usually the next step is you're taking individual sensors like the humidity sensor, like the distance sensor, and you're kind of using them in larger projects. So what I'm going to do is I'm going to reconnect that Sonar sensor. So again, I'm just plugging it into any port on my VINT hub, just like we did last time. And I'm going to plug this into my computer. Okay, I'm going to see, hopefully we can all see that on my desk. And what I'm going to do is I'm going to pull up Thonny, just like I had last time. And then I'll do Java after this, but I'm just going to get rid of that and I'll open my Sonar example. Okay, so here's that example that we saw earlier. And what I want to do is just really quickly talk about the code and make sure that everyone has an idea of how easy it is basically to get these things going. So for Python specifically, what we did was we imported that package earlier. We went to Tools, Manage Package, and we added the Phidget package. And again, this would be the same if you're using PyCharm, if you're using IntelliJ, whatever you're using, it's going to be the same type of situation. And then what we're doing after that is we're importing the libraries. So on the distance sensor, on the Sonar sensor, it actually tells you what type of sensor it is. It'll say this distance sensor on it. But this code is all available on the website. So I'll show you that after this. But that's all we're doing. We're just importing the Phidget class. So you'll always have to do that. And then we're importing the distance sensor class because we're going to be using a distance sensor. After that, we're importing time. So this is not Phidget specific. We're just using a little sleep statement down here. So I'll talk about that in a bit. But the first real piece of code for Phidgets is this right here. So what we're doing is we're creating a distance sensor. We're instantiating a distance sensor object. So we're saying, hey, I want to create a distance sensor object. And again, this is from the Phidgets class. So this is a Phidgets distance sensor. I've labeled it distance sensor. You can label it X, you can label it Y, whatever you want to label it. We just have it labeled like this for readability. And then the next step after I create the object is now I want to open the object. So the idea is that, I have this distance sensor object in software, and now what I want to do is connect it to my physical distance sensor so that they're bridged. So this is what you would do. You'd say open, wait for attachment. It's the exact same call every single time for every Phidget. And then we have a 1 second, this is in milliseconds, but this is a 1 second delay, or not delay, but it basically allows the library 1 second to find the device. So not super important. This will look the same for almost every single project you use and every single sensor. So it's just making a connection between the software and the hardware. So after we have that connection, after it gets past this line of code, we can now use the device. So, what we've done here is we've created this while loop so that we're just continually polling the device. And this is the line of code here that that actually gets the last distance value from the sensor. So distance sensor dot get distance. That will get the most recent value that the sensor has measured. And then what we're doing here is we're just putting a string around it. We're saying distance. The default measurement value is millimeters, so we're printing that out, and then we're sleeping. So again, if I run this, we can see the distance being printed. So we're just now in this loop going around, and it's waiting here 150 milliseconds between each sample. So you don't need that sleep statement. We just put it in there because the distance sensor is not, it's not measuring distance as fast as the computer can go through that loop. So we're just putting a little delay in there. If you run it without that, you can see it still works, but you're just kind of using all your computer's resources for no reason. So that's the basic overview in Python. And I'm just going to pull up the Java version of this just so everyone can see. So this is now in Java. And again, we can see a very similar format. We have the import statement. So for Java specifically, you have a jar file. So everyone who uses Java will probably be familiar with jar files. So we're just importing that jar file, and then we're creating the sensor. We're opening it just like we did in Python, and then we're using it. So the exact same setup, this time in Java. And then if we run this, we should get the same result, which we can see there. Okay, so I'm just going to take a quick pause and see if there's any questions about the coding that was confusing or did not make sense. Okay, let me see. Maybe there's not too much questions about the code. So hopefully that made sense. If you guys do have questions about the code, feel free to put it in the chat, and then we can come back to it. And then
looks like Ian has a question.
So is it the only product of its kind that's compatible with Java? Do you mean like the only Phidget, or like every Phidget sensor? So all these sensors that I listed, like the light sensor, everything like that will be compatible with all languages. Oh, I see, for education. I don't actually know. I think there's probably, I'm sure there's other tools that, I know a lot of tools have Python or like a MicroPython implementation. I'm not sure. I haven't seen as many with Java, but I'm sure there must be. So we host the Phidget library. Everything's available on our website. So if you ever want to look at the source code, everything is there. You can download all of the files, and everything is there for you. Alrighty. So I'm going to be done here pretty quickly so that I can give Peter some time to talk. But the one thing I did want to mention was just going back to the website, just so we can kind of understand the navigation a bit. If we go to the Learn tab up here, this is where your students are going to be navigating the website. So level 1, we've leveled these. So level 1 is the Getting Started kit. So again, this is just a different way you can get to that link, that tutorial. Level 2 is like what we basically just did. So if I click through to this will give us a handful of sensors that we have picked for education. So Phidgets Phidgets as the company has hundreds of different sensors. For education, we've handpicked 9 sensors right now. We keep adding to the list, but right now there's 9. And what we've done is we've kind of wrapped them in curriculum and everything like that. So if I click on the Sonar sensor that we just used, we can see here that it has a similar format to the Getting Started kit, where it has an introduction. It has this little setup image of what your student's project should look like, or their hardware should look like. And then it again has this code. So this would be this exact same code that I just ran on my computer. So everything is available there. And then we also have some applications, some practice problems, And we also have the API for advanced users. So if you want to know, like, what functions are all available and everything like that, that's all available there. And we have advanced lessons that are that teach students how to use that. So, this is how you would use the API, for example.
Hey,
But
Lucas.
these, yeah.
There is a question around, do you sell any bundled kits? So I don't know if you want to touch on like pricing
Sure.
and things that are available
Totally,
now
yeah.
or later.
So that was perfect right now, actually. So I guess I'll just end off by saying these devices here are a really good introduction, but if you are interested in other devices, like you want to use something that maybe you don't see there, you can go to justphidgets.com. And then here under these tabs, controllers and sensors, you can look at all the products. So for example, 162 products, and you'll see a whole array of products that aren't necessarily on education, but they work in the same manner, and they're available. And the cool thing is, you guys as educators get 40% off these devices. So any price you see on this page, you get 40% off. So, that's pretty cool. If you're in Canada, I'm not sure if there's any Canadians in here, but just make sure that you switch it defaults to USD. So make sure you switch it.
So,
Okay. Oh, yeah, sorry.
Follow-up question is so do you purchase them as like single sensors, or are there like bundles? So if you have like 25 students in the class, how would you navigate that?
So right now, the best thing, so in order to get that discount, because it's only available to educators, you're going to want to make sure that you go to this buy tab on the education site. And this is where you're going to want to enter your orders, basically. So for the education kit, the getting started kit, it's right now $18 US. We don't have like a classroom bundle. It's basically, you would just, if you need 10, you buy 10. If you need, you just buy whatever you buy. And our other kits are listed here. So we have a robotics kit. That's actually a really, really good value for the amount of sensors that are in there. And then we have the devices. So on this page, the devices have already been discounted 40%. So the prices you see there are the prices that you would pay. And then basically what you do, again, because we're giving special pricing for education, you would put in a PO on this site, and you wouldn't put any payment information in. We would verify that you're a school that should get this discount, and then we would figure out from there. If your school requires some schools need like a US vendor. So we do have another vendor available called Green Energy Research. So if you need to buy from an American company, that is also available. So yeah, that is the overview of that. Hopefully that answered all the questions there. I think I'm almost perfect for time. So I'm just going to leave this up. If you guys have any more questions, that would be the best thing. And I think now we're going to hand it off to Peter to talk a little bit.
So one of the things that so I walked into this job and we're teaching robotics, and does anyone work for Vex Robotics, or anyone familiar with Vex Robotics? Yeah, so that's what we had when we started, and one of the challenges that I found was just the classroom management side of that. Like, we're a great school, and so we're always full, right? Because if we had more space, we'd take more people because they want. So during the talk, Luke gave. I went and grabbed the kits, and basically, this is how much space it takes in your classroom, right? This is it. Standard USB cable, zip tied to be easy. Kids grab it, it's done. One of the things I didn't like about the Vex stuff or the Lego stuff and the other options is, first, it was a fake language or a very not common language that was hard to use. Once you left the classroom, like, it didn't translate, it didn't prepare you for the real world. That was the one thing I didn't like, particularly about the Vex stuff. The other part was just, you had all these trays of parts and these pieces, and we don't have space to keep the stuff in fully assembled condition. And so storing it, also the pieces where you spent like the pie chart of the time you spent in class, most of it was spent on Lego grade 4 activities, assembling things, and very little was spent on coding. To give you an idea of what I'm doing now is, class starts, I open this toolbox. Hey, do you mind actually stopping the screen share for a sec so I can
get totally. There you go.
So yeah, this is basically what people see. Toolbox of all the Phidget stuff, and kids snap it in and assemble it. And so someone asked, how long does it take to assemble? It took about 30 seconds to do it if you take your time. So you get really, really quickly into the learning. And that's the thing I like about it. So today, the kids were presenting what they did this term. We've got every report card is due in about a week and a half. So every other teacher's giving them assignments at the Yang. Next week is going to be just chill and relax, because I know they're going to be studying off the side of their desk. And it was basically show me what you've done. So you start off with the with the Phidget kit. And so they sort of follow the tutorials, but then, you give them the sensors, like, so what do you want to do? So one group decided to do a temperature thing where if it was cold, it was the green light. If it got warmer, it was the red light. And if it got really warm, like this beyond a 22 degrees Celsius or whatever that would be in Fahrenheit, it was blinking red, which is kind of cool. Other kids did the sensor thing. The more advanced kids, some of you are old enough to remember the arcades in the laundromat where it was the follow the blinking lights pattern. Well, they did that, and they coded it. So I like it because it's real. And it's very, very open-ended. And my other objection to the other stuff, which fake language, sometimes it required proprietary licensing and software and a computer to run it. This stuff just runs off kids' laptops. Was that it was just cheap. Like the sensors are really, really cheap compared to the alternatives because they're designed for industry. Like the Triumph folks are going to buy a pallet of these things because they need it. And the education folks, like it's a business, right? They're taking cheap sensors, which, by the way, these sensors are, I sound like a bad infomercial, are actually way more precise than the VEX stuff I found. The kids' code was great. It was basically they were doing a stoplight activity with a VEX car, and they'd hold up a green card and it wouldn't stop, not because the code was wrong, but because the sensor was so poor. And so the quality of the sensors in these things, because they're designed for professionals, were actually quite good. And so, that's my sort of love story with this stuff. It scales well, and the nice part about it also going forward is that once the kids got familiar with this plug it into your laptop kind of setup, the next step for us is going to be to run these off of Raspberry Pis or Jetson Nanos and have them independent. Because if you're an administrator or another teacher or a parent or a kid who doesn't know computer science walking past and you see a projector full of text and code, it doesn't speak to them in any way. But if they see a pumpkin that gets brighter when you walk up to it because it's running a little Raspberry Pi with Phidgets attached and a proximity distance sensor, all of a sudden that gets engaging. And so just given that catalog of different sensors, that really opens it up. And when a kid says, hey, I want to do this project, and you say, what do you need? Oh, I need this sensor and that sensor. You look at a catalog and it's going to cost you $40, and you get to, at the end of the term, put them in a toolbox and be done, and you're fine. It's tough to say no to that. And so I think the getting started part's a little daunting, but once you get into it, like there's nothing else I'd rather use. And so that's my little spiel. And as you can tell, like I kind of really like the stuff. And if you have any questions, I'm going to hang around for the end of the call, and I've got my day's done. And so I'll be here until the last person leaves.
I love how you mentioned your love affair with Phidgets. That was cute. Also, the Canadianness is getting me. Thank you so much for sharing. I think we always want to have an educator's perspective of like, how do you actually use this? And CSTA isn't about like selling anything. I'm not good at it. It's like, what can I actually use that's helpful? So I think, we definitely have a few more minutes to kind of cover any questions. I just wanted to note that, again, we'll share out the slide deck, the links, we'll share out the recording probably next week. I'll add the recording on the CSTA Plus benefit page. But I think it just seems like a really interesting kind of resource. But I'd like to open this up. If you'd like to add any questions or wonderings in the chat, now is your time. And then I think, we added a few resources that are in the chat. I'll make sure I capture those. For example, like what is the US company to go through to kind of do the ordering. If you haven't gotten your Phidgets and you're, in North America, we'll share what that link is. But looks like there's a question, Lucas, if you want to take from Anna.
Let's see. Sorry, I'm just gonna go pull up my chat. Okay. I also saw some questions about shipping to different places. So just to make that a little bit more clear. So what we've done is we've opened up this free kit offer to Canada and the US. But like Phidgets as a company, we ship all over the world. So if you are in different places, that is not an issue. So the question is about microbit or circuit playground. So I guess like it would be like, I don't know how you would want to connect it. Like if you wanted to connect a sensor, like say the humidity fidget, you wouldn't be able to do that because this is talking to the VinTub with a specific like protocol. So it's not going to be able to, the microbit will measure like voltages and things like that. So that wouldn't be something that you would probably do. Hopefully that makes sense. And I just wanted to also say thanks to Peter for sharing his information and everything like that. That was awesome. And we're collaborating on a Christmas project where we're going to use the VinTub to turn on Christmas lights in a certain temperature and stuff like that. So that's kind of a cool thing that Peter's doing as well, which I thought was pretty fun.
Yeah, and so one of the things, we've got a driveway, and like this is my existential problem. I run the IT department here, and when I teach kids, they tend to take my course again because I think I don't suck at education. But the problem is when kids in grade 8 sign up for courses, or sorry, kids in grade 7 sign up for grade 8 courses, they don't know what to take. And so this year I've got 3 kids in my programming 8 course. So the message is basically people don't know what computer science is, and there's not enough marketing. So we've got a driveway that goes past our junior school, which is a separate building, and that goes up to grade 7. And then we have our senior school. So what I'd like to do is have the Phidget running off a Raspberry Pi or Jetson Nano in a weather box. And we have some flagpoles and light standards and wrap them in LED lights. And one would be white and the other one would be blue. And if it's below freezing, the blue one lights up. And if it's above freezing, it's white. And if it's super cold or something, then you'd make them both flash or whatever. And that level of marketing where you sort of, it's a very visible thing where kids outside of junior school go like, oh my God. And the teacher explains it like there's a sales component to this whole computer science thing, right? Like if you just do good code and no one discovers it, sadly, like you're not going to get enough kids taking it. Now there's a skills gap in tech probably for that reason. And also just, I do want to get more female students in my courses as well. And so just making it visible and tangible, I think helps.
Yeah, that's awesome.
Yeah, well, CSTA is all about equity in computer science. So we're definitely trying to move that needle forward. Any other last minute questions or kind of thoughts before we wrap up?
I guess what I just want to quickly mention is, I'm just going to share my screen again quickly. This is, if you guys are interested in learning more about Phidgets in a more like a smaller environment, we have a webinar next week called Getting Started with Phidgets. So it's going to be a very similar format. I'm probably going to run it. And if you're just looking to get specific questions answered, that might be a good way to do that. So there's a sign up link on the website under the news tab. So might be something you're interested in. And just to give you guys an idea of what this was, what Peter was talking about. So we're doing stuff. This is kind of another cool thing about Phidgets is like taking it up to the next level. So in this situation, you know, we're using a web page to turn these lights on and off, and there's a lot of really cool things you can end up doing with it. So that was kind of what we were talking about with Peter there. So I think that's all I have to share. So I do just want to say thank you so much to everybody for attending and for the interest that you guys had, for all your questions. Hopefully everyone found this useful and got their questions answered. If not, here's all the links for us basically. So education@phidgets.com. That's a great place to send questions to us. Again, this is the website link. And try to follow us on Twitter if you have Twitter. We always post like projects and things like that, webinars. So that might be interesting too. And again, a big thanks to Kate and the CSTA for putting this on. We really appreciate that. And Peter, of course, thank you so much.
Yeah, of course. Awesome. So this information we'll share out. We'll share out the recording information about getting your kit. And it looks like folks have questions for Peter. So if you're comfortable, maybe we could also, Peter, if you want to share your contact information, up to you. I know I need to wrap up in a couple minutes, but I definitely want to kind of make those connections if people are open.
So what I'm going to do is I'm going to put in my Zoom room in the chat, dr-h.ca/Zoom. So yeah, and that'll take you to my Zoom room. So when Kate signs off, I'll be able to take this up in that space, and we'll take it from there, and I'll answer everyone's question until the lights turn off.
Nah, love it. That's awesome. So how does that work with your own Zoom room? Like you just copy that and then it goes to a different Zoom, or?
It's a longer conversation with a lot of moving pieces, but it's pretty smooth once it's all built. So it's I believe in making hard things look easy. So
I mean, I
and
was
this is
like, what
not,
is this magic?
yeah. So what it is, it's like Bitly just branded. That's basically what I
Okay.
did, was take Rebrandly and tweaked it. So, but that's, yes, I don't suck
That's
at IT. That's how you do it.
that's awesome. It's a great question, Susan. I don't think I can make him the host. Also, yeah, I can make him a co-host.
Oh yeah, good,
Just because
perfect.
we're recording this. Yeah, so make sure you grab that link if you would like to follow up with Peter. But thank you so much all for joining today. Excited to kind of be able to bring these opportunities to you, and everyone, please be safe. And yeah, just so excited you're able to join us. And thank you for all the work you do. We know it's really hard and crazy right now. So please take care, and we'll see you soon. Thank you.
Actually, can you make me the co-host? Can we try that?
We can do that.
Yeah, and then I think that might solve it, because I'm not above taking good advice.
No. I don't think I
Awesome.
can make you the host, but I can make you the co-host. All right.
Perfect.
Thanks, everyone.
Thank you. Thank
Okay.
you, everybody.
See ya. All right.
I'm almost there, Peter, with the Amazon thing. I don't understand the Dynamo thing. I don't get it.
Oh, if you're in Dynamo, you're ahead of me on that.
Really? Okay.
Yeah. So let's. I think as educators, you probably know Zoom by this point. So just because there's a lot, and I want to be fair, let's have hands raised. And if you could, the chat's gotten so full, I'm sort of losing track of. So maybe if we have any questions, if you could raise your hand, and I'll answer them in the order that they appear. Anyone?
Can you hear me? Can you hear me? Am I unmuted?
Yeah. So let's, Anne, you're
I'm
first.
You're free to unmute yourself.
You wanted a virtual hand raise, and I was doing a physical hand raise. I just wanted to follow up on the question about Java, because the reason that I was so interested in coming to this was I was the one who asked about it being other microcontrollers being compatible with Java. I haven't run across, now I'm not an expert in programming physical devices, but I haven't run across anything like this where you can just kind of shove a USB cable into the side of it and then start programming it in Java. I mean, Arduino, you kind of have to, I mean, I can use Java via processing on the computer, communicating across the USB or across serial cable with an Arduino that's running Arduino language, but I haven't been able to find anything where I can just plug it in and start programming it in Java. So that's really what I was driving at with my question. Is this the only, can you just confirm that you are the only providers of such a device that allows you to just shove it on USB and go?
From what I've seen, I think it is.
Okay.
But I'm not sure if I haven't really seen another device, just like you mentioned. I've seen the Arduino stuff, but that gets kind of messy and a little bit gross.
Right.
So
exactly.
This is probably the easiest way to do it, because you're just basically dragging in a jar file, and then you're just writing code in Java, and you're talking and.
Right, and that's what I'm looking for. We have engineering courses where people are doing breadboarding. So, but for the the intro Java courses, I'd like to be able to bring in an element of physical computing if possible, and this just seems like the right way to do it.
That's what we saw when we first started looking at education. We saw kind of like a disconnect where you have these programming students who are doing Java in NetBeans or whatever they're doing, but then if they want to do a physical component, it's like, okay, now let's go from computer science to like electrical engineering, basically, which is kind of a little bit, some students just, they want to do Java, right? Like you can do a lot of really cool things with Java. So that's what we saw. And that's one of the reasons that we kind of pushed harder into education, because it seems like there's a need for it. Like there's a need to, you want to stay in NetBeans and Java, and then you just want to have this nice component, this physical component. So
exactly,
that's what we saw. Yeah.
Okay, thank you.
Yeah, thank you for the question.
Anyone?
Hello. I think my general question was answered about like, is this okay for entry-level students? But I think since we're here, the larger question would be, I want to get them into Python because I've just looked into the other languages and it just seems like the most applicable for whatever field they would want to get into in CS. However, I'm kind of in a vacuum. I am like the sole computer science teacher within miles. So in terms of like transitioning them from the middle school materials that code.org provided, and now they have matriculated into high school and I'm following them around because they cannot escape me. I'm trying to think about the best way to kind of integrate this because I do think that this is probably a better option because I do have the circuit playgrounds. I received those before the pandemic, so they are unopened. So I do think that there is an application there, but the fact that this already is used in a professional setting, it just seems like this is a better investment for the department. So in terms of like getting a student from, you know, code.org, which it's not even its own like environment, it's really just like, hey, we're gonna simulate what it would look like. I have no idea what the next like transition would be. I have many notes on Thani and other things that you've mentioned, but just from your own professional standpoint, if you were in my position, what would you think would be the easiest way to get them into Phidgets? Because they have no physical computing experience at this point.
So I'm that guy. Basically, I've been faking it till I made it, like this. Don't even bother with Scratch or anything else. Just start with the tutorials. They're that simple, and like just spend some time, look at the tutorials, and then if you miss something, find a YouTube video, a short one. Like if you didn't get it the first time, the explanations are great. I hate the fake stuff. Like just start off with this, and you don't need to do Scratch. You don't need to use the little rolling Lego or whatever manufacturer makes it, the fake toys. Like skip that, just use this. And it's amazing how helpful this is because basically you need a few lines of code to import the classes at the beginning, and you explain to kids, okay, this is what this line does as you learn it yourself. And if you've taught them a little bit already, you're starting, and you and your kids are starting ahead of me. And so I've had a group of girls who just parachuted in because their parents told them to take the course, weren't passionate, didn't care, and they had a lot of success already with it. So even if you're reluctant or not that engaged, it's still good. And so you're fine.
Oh no, they're very excited to start physical.
Oh, they're ahead.
Yeah, I'm not that ahead. I had a MySpace page, so I learned HTML in high school. So I've been learning right along with them.
Yeah, exactly. A lot of us do, right? It's, I mean, just if you're honest about I'm learning with you, and you're not trying to fake the like, oh, I'm the expert. Then you have the one kid who took a summer coding camp, or his parents are developers, and you're screwed. Like, just be transparent about your learning process, and people respect that.
Oh, it's very much not that. Like in the district that I work in, the goal is to get into the trade school. Like the straight A students go into the trade school. So we're very much trying to open up like, hey, there are other jobs you can go to when you have straight A's. You know, you don't have to be confined to this urban environment where the only thing you're focused on is just getting a job straight out of high school. Do you think that in learning Python in this way with physical computing that they have a good sense of the language, or are there gaps in terms of what they might want to do? Because I do have students who are very much not interested in physical computing at all, but I'm going to force everyone to learn Python. So I'm just wondering, like, if I'm trying to fill those gaps, is there any sort of curriculum software platform that you would think would work in tandem with this?
So Microsoft has a course on Visual Studio and Python. And so what I did is I first went through the Phidgets tutorials. And then once the kids started working on it, I played it, and the thing, it was just in the background. And look, this is a quick review, and I even played it like at 1.5 times speed, just to, okay, so this should bore you. You should not be learning anything new. Occasionally, if you find something new, we'll stop it, pay attention. And to be honest with you, the tutorials are so good on the Phidget site that very little was new. And so a lot of the kids decided to not even play with this by the time their projects were due. I let them do like, look, do something with Python. Could be this, could be something else. And some of them just decided to do text-based games. So choose your own adventure stuff. But because they learned the principles using this, it was all fine. So whatever your kids want to do, once they sort of just understand Python, you're fine.
That is a really good idea. I am like many great teachers who have come before me. I'm going to steal that idea.
Steal away.
I think having the pathway diverge is like a really good end for that. So
Yeah.
those are my questions, but I will probably be a fly on the wall in case there's any other information coming out.
And some kids have Chromebooks, and so you just partner up with a kid who doesn't have a Chromebook or has a MacBook or a Windows machine. They plug it in, they watch the code. You maybe use Google Docs to sort of co-write an experiment and copy and paste it in once they're done. And then the kid understands it. Then he's like, okay, I want to either use a physical device, or a lot of those kids with Chromebooks decide, okay, I know enough. I'm just going to do tech stuff.
No, that's a great idea. I mean, the fact that you even had them collaborating on a Google Doc is like, I should have thought of that, because I've often just tried to do the whole paired programming, but then you can't actually see the line by line progression of like what somebody's added. You can only see if they've made a mistake because the debug will pop up.
And as we're talking about pairing kids, I just did a IEEE conference in Munich about our COVID response, and they were talking about team pairing. And there's there's the best worst student combination, then there's a similar level. And the consensus from the group was that similar level is the way to go, because similar kids, even though they might be the not so awesome kids, they're going to learn from each other, versus pairing best and worst, where the best kid does all the work and the worst kid still doesn't learn. So I would suggest that and let them sort of do open-ended projects.
That is also a good idea. I will be staying here to take notes on great ideas.
Anyone else? Anyone else? Hey, Chris.
I saw there was a webinar, a past webinar about using Raspberry Pi, that the replay wasn't available, and I was kind of hoping that was going to happen. I'm hoping it's a delay and hasn't been posted yet, because that is something I'm really interested in. And I can see this working for my students, because I'm in Texas, and in Texas we count programming as a foreign language. Every high school student in Texas has to take 2 years of a foreign language, and they decided that coding counts. Well, that means that over 50% of my students just want their foreign language credit. And so the buy-in is not there, and I struggle with that. And I can see how this would add a sense of buy-in, because they're not just sitting at a computer writing code, which is boring for a kid that is only in there because they didn't want to take Spanish. But this would give them something physical, and I am intrigued about how these work with a Raspberry Pi, because I'm a big Raspberry Pi fan.
So let me tell you the application for us. And the Python language came because I was looking at how do you get rid of the Vex stuff that we had. Like, that wasn't something we wanted to do. And so how do you prepare our kids for careers in the cloud? And that was Amazon. So what does Amazon use for their machine learning, artificial intelligence stuff? Okay, they use Python. Okay, good to know. And so we started playing during COVID with some machine learning deep racer stuff using the Amazon platform. So I put my email down there, and if you want to use Python and do a competition or a collaboration with Python and deep racer, that's definitely an option, and I think your kids would love it because it's simulation cards that have machine learning on it. But to understand the code that drives the reinforcement learning functions, you need Python. And so the tutorials in the Phidget stuff are so good that creates a great foundation. Like, I had to reverse engineer it with nothing, and my kids and I were able to figure it out, and we're okay. The Phidget curriculum first, and then using the deep racer cars, which required $0 of outlay on your end, because it's all subsidized, because Amazon basically subsidizes the software development track so that they don't have to pay top dollar for very few engineers. They can pay what they're paying now and not more as they raise the number of engineers that are available. So that's their long game, right? So yeah, this is phenomenal as a starting ground. And if you want kids to not be bored, the deep racer stuff is awesome. So my email's in the chat, and yeah, just reach out to me offline.
Just to answer your question, Chris, about just like the webinar. So that video probably will not be posted. It's not going to be posted because the reason why is it's like beta content in that
Okay.
webinar. So what I did is I posted a link in the chat, bit.ly Phidgets_pi, and that will bring you to the presentation that I used on that webinar. And that will give you kind of like all the information you need to get started. And again, right now, the Pi stuff is in beta.
Okay.
By January of next year, or by this January coming up, we'll have an option on the getting started kit to select the Raspberry Pi as like an operating system. So we saw like Windows and Mac, for next semester, there'll be a Raspberry Pi selection and it will give them the information. So we're just waiting on a few things to be put in place. But that being said, you still can use it. Me and Peter are doing a kind of like little joint project right now with the Christmas lights. And I have a Raspberry Pi in my house right now controlling my Christmas tree and all that stuff. So if that's something you want to do, that is the link. And I can always jump on a Zoom call with you. So I'll put my email in the chat. So if you have any questions or like you're having issues getting it running, you can just email me and we can jump on a Zoom and I can make sure that you're up and running with it.
And
Awesome.
by the way, the Raspberry Pi Christmas light project, the goal was to have a 12 volt or whatever the receptacle plug that allows you to buy anything on Amazon, short of like a leaf blower or something powerful, and run it using using Phidget stuff, and have remote control over it. So like that's like, show me another manufacturer that does that. I don't see that. So this is why I like it.
Yeah, I'm blown away by this. So, well, thanks, guys. I have little ones I got to get put in bed, but thank y'all very much. This was great. I can't wait to go bring this back to my campus tomorrow.
Awesome.
Yep.
Thanks so
And
much for coming.
I'm not being polite. I really mean it. Reach out to me by email.
Will do. Thank you very much.
Anyone else? Anyone else?
Any other questions?
And that invitation extends to everyone. So it's just reach out if you want to do some Python-based machine learning, artificial intelligence stuff. It's really way easier than you'd think. And the Phidget stuff was a really good foundation. And then you get to show your bosses, look, our kids are doing AI, machine learning, self-driving car stuff. And they'll be like, wait, what? Don't leave us for a better job.
That's awesome. Cool.
Aletta, Lionel, Murshed, phone numbers, Ellen, anyone?
I don't have any more questions, but thank you guys so much for hanging out and letting me be a fly on the wall for the things that you're doing. I don't know if I'll be reaching out for any machine learning anytime soon because I don't know if we'll get there. It's been a very complicated year, but I would love to reach out just in general to just hear about what you guys are doing because I think especially since like my experience in this field is so very limited and like I have no colleagues to kind of lean on and be like, oh, what are you working on? Just even hearing that you're using the Raspberry Pi for Christmas lights is like very, very much putting me in a headspace in which I'm like, oh, we can do more than just the small amount of things that I was envisioning.
Well, the machine learning thing actually happened last year by accident because our plan was to use this stuff. Mm-hmm. And then we went to lockdown and we couldn't come to the school. So I kind of had to change the sequence. And so, but it's not so bad. And so once you get this, you'll be like, oh, that's actually not so bad.
Oh, I think they're going to love it. It's just, yeah, it's been a very, very complicated year.
Yeah, definitely. Awesome. So have a good evening or good evening.
Thank you for coming. I don't know if anyone is, they might be away from keyboard.
Fell asleep at their computers.
Yeah, exactly. Ellen is a Phidgets plant. She's helping out with education.
Oh, nice.
So she's one of us, just hanging out and trying to see what's happening.
All right. Well, on that note, I shall conclude. The recording is probably going to end when we leave. So. Yeah.
Thanks again so much, Peter, for everything. Really appreciate that.
Oh, hey.
I'll try to get you an update with the Alexa thing. I'm like close. I'm on that. The only thing I don't know if you understand this. What is the difference between a Amazon Developer Console? I don't know if you guys do that. Do you use the Amazon Developer Console?
I mean, AWS Console is all the tools, storage, EC2, and all that stuff.
So what I'm seeing is like to actually, I guess, just to talk to an Alexa, there's this thing called an Amazon Developer Console. And then on the other side, there's this AWS thing, which is I think what you're talking about, which is like all the tools and the databases and all that.
Yeah.
So, okay.
Well,
Yeah,
I think,
I'm trying to link the two right now because I have the Alexa skill. These things, I
yeah,
don't know.
I was going to say skill. Yeah, that's
The skill has a default database like attached to it, but that database is not the database of my account, my AWS account. So I'm like, I don't understand how this stuff works. So that's what I'm trying. That's like my hurdle right now. And the documentation is online. It's hard to. It's like you either have like a total newbie or like some crazy Amazon engineer who's like. So anyways, that's what I'm trying to figure out right now. And I'm doing it for my own tree. So I'm like, I gotta get this going.
if you get to a point where you really want me to reach out, I've got enough contacts where I can probably get you helped with that.
Okay,
so if you sort of get to a dead end, like where, okay, I really don't have any other options to explore. I'll send an email. Like I try to be polite about it the same way I try not to bug you too much. So yeah, but if that's the case, I think they would love to hear about what you're doing, because this is there's synergies here, right? Like you teach them the physical stuff, and then they might use the AWS stuff. So
totally. Yeah, I was impressed with how actually easy it was. I didn't even really realize of that whole ecosystem. Like the people are, it's like basically like an app store, right? Like they're creating these skills. I guess they're monetizing them in some way because there's.
Yeah, so they charge you for compute use, and so basically it's they figured out their whole infrastructure, how to deliver that box to you, and other companies are like, hey, you've got it good, let's use it, and they're like, fine, we'll let you use the storage, fine, we'll let you use the compute, and all of a sudden they figured out how to monetize it, and it's pay per use, so it's fair. It's if you're like
that's like the skills. Like, so if someone makes a skill, like Alexa, how many whatever, like what's my birthday, like that, you can monetize that thing too, right? Like that, it's like an app that you're creating. Like
you know what, if it's running on the platform, I'm sure that whatever compute you use to run it, they monetize, but it's not like the App Store where they charge you 15 or 30%, whatever that is now.
I see. Yeah, it's actually pretty cool. I had this Alexa thing in my house for like 3 years, and I was like, all right, we'll use it for this project.
Hey, awesome. Cassandra, I see your face there. Do you have any questions, or did you just hang out with us by accident?
Oh, I don't know if she all righty, I guess.
All right.
I lost service earlier, and I was trying to get back in before you all ended. I'm sorry.
So we didn't end. So do you have any questions? You got a VIP treatment now.
Well, no, I'm excited. While you were going over it, I was sitting here and I was able to.
Awesome.
Awesome.
So now I'm about to buy me a rover kit. So.
Thank you.
We use those actually, and so what our kids, one of the kids in my class, he's taken the vent plugged one out of this thing, the starter kit. He's using the rover kit, and so he's got this little this joystick unit here. He's got this thing. I don't know. Does the rover kit come with a joystick?
Yeah, it does. Yeah.
So he's using that and driving it around the class as other kids are, making their lights. So he's the advanced kid showing off, which is awesome. I'm like, yeah, if you figure this out, you get to show off too. So rover kit's good money.
I enjoyed the webinar, and I'm going to sign up for the next one as well.
Awesome. Thank you so much, Cassandra. Appreciate that.
All right. Y'all have a nice evening.
You too. Thank you.
Yeah.
All right. We had a kid who he put like a Raspberry Pi basically on his rover kit instead, and he drove it all around the school, and he was collecting all the different Wi-Fi networks, and he mapped them. Like he did like this thing with like Wi-Fi networks and strength, and he drove it all over the school. It's pretty cool.
That's awesome.
Thing. Anyways, I guess that's good for today. Hopefully everyone who's left here is just has all their questions answered. So if not, reach out to myself or Peter. And thank you everybody for joining. And thank you again, Peter, so much. We really appreciate it.
Oh, hey, if your product sucked, I wouldn't be here, right? So
thank you.
Thanks so much.
All right,
take care.
Guys.
Bye.